Special relativity is a theory in physics. It concerns light, its speed, objects in motion, speeds and high velocities, and frames of reference, that is, what you see from your own perspective. There are two parts to this theory. The first is the principle of relativity. The relativity principle states that the measurements of time and space are relative, and one's view of an event may not be the same for another if they are at two different positions, because they would have different reference points. Think for a second. Are you moving? You might say no, you're standing still, but take a look. The Earth spins at around 1,000 miles per hour. It orbits the Sun at an even faster speed, which itself is orbiting around our galaxy. Are you really still? The answer is yes, you're not moving relative to the Earth. But what does this have to do with perspectives? Well, when you said you were still, it was from your point of view. From the view of, let's say, God, you could be moving really, really fast. This also applies to when both people are moving, like on a highway. You're in a car going 88 kilometers per hour, and the car next to you is going 90. That car would seem like it's going 2 kilometers per hour, because it is that much faster than you. This logic works for everyday speeds. However, things get tricky when you start getting to higher velocities, like the speed of light. That's what the second part of special relativity is about, light and its speed. The speed of light is around 671 million miles per hour. It can be denoted by the letter c. The speed is measured speed in vacuums, which means spaces where no matter exists. It will slow down in glass, water, and gases. The speed of light is considered to be a sort of galactic speed limit. Nothing can be measured faster than 671 million miles per hour. Time dilation, that is, slowing of time, starts to be apparent around 10% of c. At 100% of c, time stops. Other funny things start to happen too, like shortening of length and increase in mass, so that c is always c. Because of that, you can't just start adding and subtracting speeds when you're reaching near the speed of light. This equation is used to figure speeds out. However, I'm not a math teacher, so I won't be able to explain it too well. By the same token, I'm not a physics teacher either, and there is obviously a lot more information than I can give or explain in this short video. Hopefully you understand the basics of special relativity now. Thanks for watching.